Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that the size of side AC of the triangle is 2 units. The size of side BC of the triangle is 8 units. And we also know that the centroid of the triangle is at point G. Actually, the centroid of any triangle is the point where the three medians of the triangle intersect. Okay, so the centroid of this triangle is at point G, and we also know that line segment DE is parallel to side AB of the triangle, and we know that DE belongs to the natural numbers. That is to say, the size of DE is a natural number. And we have to find out the size of DE. Okay? So, first of all, we have a rule that actually in any triangle, if we have a triangle ABC, that can be any triangle. Triangle ABC can be any triangle, and we know that point G is the centroid of the triangle, and AD is the median of the triangle. That is to say, AD divides side BC to two equal parts, or in other words, AD bisects BC. That is to say, BD equals to DC. Then the centroid G divides the median AD in a ratio of 2 to 1. So if AG is 2 units, then GD will be equal to 1 unit. So in other words, AG over GD equals to 2. Or AG is twice than GD. Okay, AG equals to 2 times GD. Okay, so we can implement this rule in our triangle ABC. So in any triangle, if G is the centroid of the triangle, then AG over GD will be equal to 2, or the centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, AG over GD equals to 2. Okay, so we can implement this rule in our triangle ABC. We know that G is the median of triangle ABC, Therefore, it divides the median CF in a ratio that equals to 2 to 1. If CG is 2, then GF will be equal to 1. Okay? Or we can write down that CG over GF equals to 2. CG over GF equals to 2. Or if we define CG as 2y, from here we know that CG equals to 2 times GF. We multiplied this equality by GF and we got that CG equals to 2 times GF. Then we can substitute the value of CG by 2y because CG equals to 2y according to our definition. So we will substitute CG by 2y and we will get that 2y equals to 2 times GF. Then we will divide this equality by 2 and we will get that y equals to GF. Okay, so we found out that if CG equals to 2y, then GF will be equal to y. So if CG equals to 2y, then GF will be equal to y. Okay? And we have also the second rule. The second rule states that in any triangle, if we have a triangle ABC that can be any triangle, and we know that DE is parallel to BC. If we know that DE is parallel to BC, DE is parallel to BC, then according to this rule, AD over DB will be equal to AE over EC. Again, I will repeat on the rule. The rule states that if in triangle ABC that can be any triangle, we know that DE is parallel to BC, then AD over DB will be equal to AE over EC. And again, we can implement that the second rule in our triangle. We actually know that DE is parallel to AB. Okay, we know it is given us in the question that DE is parallel to AB. DE is parallel to AB. Therefore, if we relate to triangle ACF, in triangle ACF, DG is parallel to AE because DG is part of DE and AF is part of AB, and we know that DE is parallel to AB, therefore DG will be also parallel to AF because DG is part of AE and AF is part of AB. So because of the fact that DG is parallel to AF, according to this rule, because of the fact that DG is parallel to AF in triangle ACF, we can write that CD over AD or CD over DA equals to CG over GF. I will repeat again. In triangle ACF, this triangle, we know that DG is parallel to AF. Therefore, according to this rule, we can conclude that CD over DE, CD over DA equals to CG over GF. But what is the value of CG? CG equals to 2y. What is the value of GF? GF equals to y. So in total we got this equality. 2y over y is 2. So actually we found out that CD over DA equals to 2. And if we multiply this equality by DA, we will get that CD equals to 2 times DA. CD equals to 2 times DA. So actually, if we define CD as 2x, so CD will be equal to 2x according to our definition, then we will substitute CD by 2x in this equality, and we will get that 2x equals to 2 times dA. Then we will divide this equality by 2, and we will get that dA equals to x. So we found out that if CD equals to 2x, then dA equals to x. If CD equals to 2x, then dA equals to x. Okay? So we know that line segment DE is parallel to side AB of triangle ABC, and because of the fact that DE is parallel to AB, we can conclude that those two angles are equal to each other. This angle, angle BAC, is equal to angle GDC. Okay? So, angle CDE is equal to angle CAB. and those two angles are equal to each other, this angle equals to this angle, according to the rule that corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. Again, angle CDE is equal to angle CAB according to the rule that corresponding angles between parallel lines are equal to each other. Okay? So, if angle CAB equals to alpha, then angle CDE will be also equal to alpha because those two angles are equal to each other. And for the same reason, angle CBA equals to angle CED. Angle CBA, this angle, is equal to angle CED, to this angle. So if angle CBA is equal to beta, then angle CED will be also equal to beta because those two angles are equal to each other. I will repeat again, angle CBA equals to angle CED equals to beta according to the rule that corresponding angles between parallel lines are equal to each other. Line segment DE is parallel to line segment AB, therefore those two corresponding angles will be also equal to each other. So if this angle is beta, this angle will be also equal to beta. Okay, so in the next step, we will focus on triangle, the big triangle, triangle ABC. Triangle ABC and triangle CDE. So we'll focus on triangle ABC and triangle CDE. Again, we will focus on triangles ABC and triangle CDE. On those two triangles, we know that angle CDE on triangle CDE is equal to angle CAB on triangle ABC, and both those two angles are equal to alpha. Okay, angle CDE equals to angle CAB equals to alpha. And we also know that angle CED is equal to angle CBA, and both those two angles are equal to beta. Okay, angle CED equals to angle CBA, and both those two angles are equal to beta. And also we have this angle C, that is actually a common angle. It belongs to both triangles. So angle C equals to angle C. Angle C belongs to triangle CDE, and angle C also belongs to triangle ABC. So angle C equals to angle C. It is actually a common angle. Okay, angle C equals to angle C. So we actually proved that all the angles in triangle ABC are equal to all the angles in triangle CDE. So we actually proved that triangle ABC is similar to triangle CDE according to angle rule similarity. Okay, triangle ABC is similar to triangle CDE. This is the sign of similar. Triangle ABC is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? Actually, if you prove that all the angles of one triangle are equal to all the angles of the other triangle, then you prove that those two triangles are similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC is equal to DE over AB. I will repeat again. Because of the fact that triangle ABC is similar to triangle CDE, we can conclude that the following relationship exists between the two triangles, that is to say CD over AC equals to DE over AB. Okay? But what is the value of CD? CD equals to 2x. And what is the value of AD? AD equals 2x. So here we got 2x over x is 2. So we write it down. 2x over x is 2. So in total we got that DE over AB equals to 2. Actually, I made here a mistake because CD is indeed 2x, but AC is not x because AC is actually 2x plus x. So AC is 2x plus x, that is to say AC equals to 3x. Okay, so AC equals to 3x, and 2x over 3x is 2 over 3. So we found out that DE over AB equals to 2 over 3. Here we will multiply this equality by AB, and we will get that DE equals to 2 over 3 times AB. Okay, we found out that DE equals to 2 over 3 times AB. DE equals to 2 over 3 times AB. And we have another rule. In any triangle, if we have triangle ABC, and we know that the size of side AB is A units, and the size of side AC of triangle ABC is B units, and the size of side BC of triangle ABC is C units, so it is. Then side BC of triangle ABC that that its size is C units, will be less than A plus B, and C will be greater than A minus B, the absolute value of A minus B, and this rule is true in any triangle, because triangle ABC can be any triangle. Actually, what the rule says is that the sum of the two sides of a triangle is always greater than the third side, and the difference between two sides of any triangle is always smaller than the length of the third side. For that reason, C will be less than A plus B, because the third side is always less in the length from the sum of the two sides of the triangle, and the difference between two lengths, or the length of two sides is always smaller than the length of the third side. So we can implement this rule in our triangle ABC. So according to that rule, we can say that AB is smaller than AC plus BC, and it is greater than AC minus BC in absolute value of AC minus BC. Again, side AB of triangle ABC is smaller than AC plus BC, and it is greater than the absolute value of AC minus BC. We know that AC equals to 2 units, BC equals to 8 units. This is given us in the question. So in total we will get that AB is smaller than 10 and is greater than the absolute value of 2 minus 8, that is minus 6. AB is less than 10 and it is greater than the absolute value of 6. The absolute value of 6 is 6 because the absolute value of any number is the distance of the number from 0. The distance of minus 6 from 0 is 6 units. Therefore, the absolute value of minus 6 is 6. So we got that AB is greater than 6 and is smaller than 10. But we have already found out that DE equals to 2/3 AB. Okay? Here we will multiply this expression by 2/3, and we will get that 2/3 AB is smaller than 2/3 10, 2/3 times 10, and it is greater than 2/3 times 6. So 2/3 times AB, it is smaller than 2 times 10 is 20, and 20/3 is 6.66. And here we have 2 times 6 is 12, 12/3 is 4. So we got that 2/3 AB is less than 6.66, and it is greater than 4. But what is 2/3 AB? 2/3 AB equals to DE. So we can substitute 2/3 AB by DE. So we will get that DE is greater than 4, and it is smaller than 6 times 6.66. Okay? DE is smaller than 4, and it is greater than 6.66. But we also know that DE is a natural number. DE belongs to the natural numbers. Okay, so which natural numbers we have that are greater than 4 and smaller than 6.66? We have 5 and 6. So DE can be equal either to 5 or 6. So we found out that the value of DE could be 5 units or 6 units. That is the answer to the question. The value of this line segment DE could be 5 units or 6 units. Okay, DE can be 5 units or 6 units. Okay, now I will summarize the lecture. Actually, we wanted to find out the value of DE. And we know that AC equals to 2 units, BC equals to 8 units. G is the centroid of the triangle. What is centroid of a triangle? Centroid of any triangle is the point where the three medians of the triangle intersect. At the centroid, the three medians of the triangle intersect with each other. And we also know that DE, the size of DE, belongs to the natural numbers, and we want to find out that size, the size of DE. And we actually have the rule that in any triangle, if we have triangle ABC, that could be any triangle, if G is the centroid of triangle ABC, and we also know that AD is the median to BC, that is to say AD bisects BC, or in other words, AD divides BC to 2 equal parts, that is to say BD equals to DC, then according to that rule, the centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay, that is to say, AG is twice as larger than GD, or AD equals to 2 times GD. Okay, the centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, AG over GD equals to 2. Okay, or if you multiply this equality by GD, we will get that AG is twice as large as GD. AG equals to 2 times GD. Okay, so if we relate to our triangle ABC, we know that G is the centroid of the big triangle ABC. And according to the rule that I mentioned, the centroid G, this centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then CF will be equal to 1 unit. Okay? Or CD over GF equals to 2. Okay? According to the rule that I mentioned, the median G in triangle ABC divides the centroid G in triangle ABC divides the median CF in a ratio that equals to 2 to 1. That is to say, CG over GF equals to 2. 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 If we multiply this equality by GF, we will get that CG equals to 2 times GF. CG equals to 2 times GF. And if we define CG as 2y, that is to say CG equals to 2y, then we will substitute CG in this equality by 2y, and we will get that CG equals to 2 times GF. We will divide this equality by 2, and we will get that y equals to GE. That is to say, if CG equals to 2y, then GF will be equal to y. Okay, so if CG equals to 2y, then GF will be equal to y. Okay, then we have the second rule. The second rule that it is true in any triangle. The rule states that if in triangle ABC that could be any triangle, we know that DE is parallel to BC. DE is parallel to BC, then AD over DB equals to AE over EC. So again, if we know that in triangle ABC DE is parallel to BC, then AD over DB equals to AE over EC. And again, we can implement this rule in our triangle, because in our triangle we know that DE is parallel to AB. It is given us in the question. DE is parallel to AB. So, because of the fact that DE is parallel to AB, if we relate to triangle ACF, the small triangle ACF, according to the rule that I mentioned, in triangle ACF, because of the fact that DG is parallel to AF, because of the fact that DG is parallel to AF in triangle ACF, we can state that CD over DA equals to CG over GF. Again, in triangle HCF, this triangle HCF, you know the CG is parallel to AF. In triangle HCF, we know that DG is parallel to AF. Therefore, according to the rule that is stated, CD over AD equals to CG over GF. Okay, CD over DF equals to CG over GF. But what is the value of CG? CG equals to 2y. What is the value of GF? GF equals to y. So here we can substitute CG by 2y and GF by y. 2y over y is 2. So we found out that CD over DA equals to 2. Okay, we can multiply this equality by DA and we will get that CD equals to 2 times DA. CD is twice as large as AD. Okay, CD equals to 2 times AD. Therefore, if we define CD as 2x, if CD equals to 2x according to our definition, we can substitute CD in this equality by 2x and we will get that 2x equals to 2 times AD. Then we will divide this equality by 2 and we will get that DA equals to x. So we found out that if CD equals to 2x, then DA equals to x. So we can write in the drawing that CD equals to 2x and AD equals to x. Okay? And we also have the rule that states that corresponding angles in parallel between parallel lines are equal to each other. According to the rule that corresponding angles between parallel lines are equal to each other, we actually know that DE is parallel to AB. Therefore, the corresponding angles, those two corresponding angles, will be equal to each other because of the fact that they are located between parallel lines. And the rule is that the corresponding angles between parallel lines are equal to each other. So those two angles will be equal to each other. That is to say, angle CDE will be equal to angle CAB, and if angle CAB equals to alpha, then angle CDE will be also equal to alpha. Okay? Those two angles that are located between parallel lines are equal to each other according to the rule that they mentioned. And we have the same rule also for these two angles. Those two angles are located between parallel lines. The parallel lines are DE is parallel to AB, and those two angles are located between those two parallel lines. Therefore, they are equal to each other. That is to say, angle CBA is equal to angle CED, and if one angle will be defined as beta, then the other angle will be also equal to beta because those two angles are equal to each other. So we found out that angle CBA equals to angle CED equals to beta, and angle CD equals to angle CAB equals to alpha. Okay, so in the next step, we will focus on the big triangle, triangle ABC, and on the small triangle, triangle CDE. Okay, so on those two triangles, we know that those two angles are equal to each other. Both of them are equal to alpha. Angle CDE equals to angle CAB equals to alpha. And we also know that angle CED equals to angle CBA equals to beta. Those two angles are also equal to each other and both are equal to beta. Okay? And we also know that this angle, angle C, is a common angle. It belongs to both triangles, so we can write down that angle C equals to angle C because of the fact that angle C belongs to both triangles. So we actually proved that all the angles in the big triangle ABC are equal to all the angles in the smaller triangle, triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. What is angle similarity rule? Actually, if you prove that all the angles of one triangle are equal to all the angles of the other triangle, then those two triangles are equal to each other according to angle similarity rule. Okay? So from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Again, CD over AC equals to DE over AB. Okay? CD over AC equals to DE over AB. But what is the value of CD? The value of CD is 2x. Okay, CD equals to 2x. What is the value of AC? AC is actually CD plus AD, or AC is 2x plus x. That is to say, AC equals to 3x. AC equals to 3x. So CD over AC is actually 2x over 3x. X over x is 1, so x will get cancelled, and we left only with 2 over 3. So we found out that DE over AB equals to 2 over 3. We will multiply this equality by AB, and we will get that DE equals to 2 over 3 times AB. So we know that DE equals to 2/3 AB. Okay? Then we have the rule that in any triangle, the sum of two sides of the triangle will be greater than the length of the third side. That is to say, A plus B will be greater than C, and we also know that the difference between two sides of any triangle will always be smaller than the length of the further side. That is to say, A minus B in its absolute value will be always smaller than the length of CB, that is actually C. Okay? Again, the rule says that in any triangle, the sum of the two sides will be always greater than the length of the third side, and the difference between two sides will be always smaller than the length of the third side. That is to say, BC that equals to C units will always be smaller than A plus B, and will always be greater than the absolute value of A minus B. Okay, so again, we can implement this rule in our triangle ABC. If we relate to side AB of triangle ABC, we know that AB will be always smaller than the other two sides of the triangle. That is to say, will be always smaller than AC plus BC, and AB will be always greater than the difference between the two sides, the other two sides of the triangle, that is actually AC minus BC, in its absolute value. Okay? But we know that AC equals to 2 units and BC equals to 8 units. Okay, so we get that AB equals, it is smaller than AC is 2 and BC is 8, will be smaller than 8 units, and we will be greater than 2 minus 8, that is actually minus 6, and the absolute value of minus 6 is 6. So we found out that the value of AB is actually AB is greater than 6 and it is smaller than 10. But we have already found out that DE equals to 2/3 AB. Okay? So we will multiply this expression by 2/3 and we will get that 2/3 AB is smaller than 2/3 10 and it is greater than 2/3 6. 2/3 6 is 4 and 2/3 times 10 is 6.66. So we found out that 2/3 AB is greater than 4 and it is smaller than 6.66. But what is the value of 2/3 AB? 2/3 AB equals to DE. We have already found out that 2/3 AB equals to DE, so we can substitute 2/3 AB by DE. Okay? We substituted 2/3 AB by DE and we got that DE is greater than 4 and it is smaller than 6.66. But we also know that DE is a natural number. So which natural numbers we have between that are greater than 4 and that are smaller than 6.66? We have only 5 and 6. So we found out that the value of DE will be equal to either 5 units or 6 units. So the answer to the question is that the value of DE or the size of DE is either 5 units or 6 units. And that is the final answer to the question. Okay? Thank you very much.